In this video, we will try to solve a problem that was asked by a person on Telegram channel of Econ Methods regarding how to find the tax rate that maximizes the government revenue. The question is like this: a monopolist is following total revenue and total cost function. R is equal to minus mQ² plus nQ, where R denotes the total revenue, Q is the quantity, and M and N are the parameters that are greater than 0, and total cost is given by aQ² plus BQ plus C, where A, B, C are greater than 0. Suppose government plans to levy an excise tax, on the production of this firm and wishes to maximize the total tax revenue T from this source. Okay, what tax rate in dollars per unit of output should the government choose? Okay, so let's see how to solve this question. Okay, first of all, we are being given the total revenue function. Let me write it like this. So our total revenue function is R is equal to, let me write this term first, that is NQ. Okay, it does not make any difference whether I write the first term or the second term first. Okay, so then we have mQ². Okay, this is our total revenue function. And what is the cost function? Cost function of the monopolist is being given as aQ² plus BQ plus C. Okay, this is the cost before the imposition of excise tax, which obviously is a per unit tax. Okay, so this is the cost before the imposition of tax. Now after tax is imposed, let me write here after tax. Okay, what will be the cost? Let's denote it by C star C dash is equal to this total cost plus TQ. Okay, I hope I am making myself clear. So let us differentiate between this plus and T. Okay, let me write the small one here. Okay, so after the imposition of per unit tax, what will be the cost function? This is the total cost function. Okay, when tax is imposed per unit of output, then a new cost will be equal to original cost plus tax per unit of output. Okay, I hope I am making myself clear. Okay, now what is the profit function? Let us write what is profit. Then profit is simply revenue, that's total revenue minus this cost after the imposition of tax. Okay, so our revenue function is this. Let me write it here. So we have nq minus mq². Okay, to this we subtract this cost. So let me uh, further rewrite this function. So this can be written like this. So original our C was this aQ² plus BQ, okay, plus C. Then we have this TQ plus TQ. This becomes our new cost function. Okay, this is our total revenue. To this we subtract this cost. What is the new cost? This very cost. Okay, so this will become minus aQ², because this minus is multiplied to each of these terms. Okay, then we have minus BQ minus C minus TQ. Okay, so this is our profit function. Sorry for the interruption. Now this is our profit function after the imposition of tax. Now what are the conditions for profit maximization? So we have two conditions for profit maximization. Okay, what we call the, let me write it here, profit maximization requires that we should satisfy two conditions. That is, first order condition is like this. First order condition tells us that the derivative of profit with respect to quantity should be equal to 0. Okay, this is our profit function. We take derivative of this profit function with respect to q and set it equal to 0. Okay, so let me write it here. The derivative of q is 1, so we are left with n minus the derivative of q² is 2q. Okay, this 2 becomes coefficient. This exponent is subtracted by 1. Okay, I will not explain. I have explained it in number of videos. You can check. Okay, so this becomes twice mq. Okay, then we have minus. Similarly, derivative of q² will become 2q, so this is 2aq minus derivative of q is here 1, so we are left with b. Since no q is involved in this term, so its derivative will be 0, minus the derivative of q here will be 1, so we are left with t, and we set it equal to 0. This is the first order condition. Now sorry, let us solve this very expression for q. Okay, if I transpose these two terms, they will become positive. Minus 2m q minus 2aq. If I transpose them, they will become 0. Positive. So let me write it like this. We have 2mq plus 2aq. Okay, when I transpose this, so they became positive. Then we are left with n minus b. Sorry, this is b here, minus t. Okay, now taking 2 common, if we take 2 and q common, so we are left with 2 q m plus a is equal to n minus b minus t. Okay, now sorry, we can write q star, that is equilibrium profit maximizing quantity, will be equal to n minus b minus t. Okay, and we transpose this term, this m plus a and 2 to RHS, and it will get divided, so we are left with 2m plus a. Okay, this is our profit maximizing level of output after the imposition of tax. Okay, this is the first order condition. Now what is the second order condition? Second order condition tells us that the derivative of second derivative of profit function with respect to quantity, okay, should be less than 0. Why are we using these two properties? Let me explain it here if I have time here. So let us say this is our profit function. Okay, first order condition is applied where the slope of the profit function is 0. So this, let us say this is a point where if we draw a tangent, okay, so let us say this is a point where slope is 0. So first order condition requires that the slope of the profit function should be equal to 0. What we mean by the slope? That means we should have a flat line here. Okay, that means the slope of a flat line is always equal to 0. Okay, so this is the first order condition, or if I can write it like this, this is d pi upon dq. Okay, and second order condition is always applied, also applied here, to check whether after attaining the maximum value our profit function should be decreasing. Okay, so to make it sure, we use the second order condition, that is d square pi upon dq square should be less than 0. Okay, obviously when we reach it to this point, and if we want to go further, the slope will become negative, and this is satisfied by this condition. Okay, at this point the slope is 0. Okay, so it is sometimes required to check the second order condition also. Okay, so this could have been like this also if we have this very function. Okay, this is the minimization function. Here the slope is also equal to 0, but we are not sure whether this is the minimum part or not, minimum part or maximum. To differentiate whether this point is minimum or maximum, we take the second derivative. If second derivative comes out to be negative, then we have maximum value. If second derivative comes out to be positive, obviously here that let me write here, if we have d pi upon dq, if it comes out to be 0, at this point it is also 0, at this point it is also 0. This is the first order condition. Okay, now second order condition is used to check whether after attaining maximum our the slope decreases. Okay, but here we can see first order condition is satisfied in both the conditions. To differentiate between maximum and minimum, we use the second order condition. What is the second order condition here? This is d square pi upon dq square. Here it will be greater than 0. If we want to find the minimum point, then we have to check this second order condition. If we want to find the maximum point, to make sure we are at the maximum, we need to check the second order conditions, obviously. Okay, so it was off the record. I hope you know these stuff very well. So till mutabi, we will focus on the question. Okay, now why do we have taken here the first derivative. Okay, this is the first derivative. Now second derivative of this profit function with respect to quantity should be less than 0. And let us see, taking second derivative here with respect to quantity to this is the first derivative. Second derivative is simply the derivative of first derivative. I hope I am making myself clear. So since q is here, the derivative of q is 1, so we are left with minus 2m. Okay, here also we have q, derivative of q is 1, so we are left with minus 2a. Okay, and we can easily see this is less than 0. Okay, now you can say that, okay, well, what happens if this a is less than 1? It is negative number. But this thing has been already been clarified that these numbers a, b, c are greater than 0, m and these are greater than 0, so there is no way that this whole thing will come out to be greater than 0. Okay, so both conditions are satisfied. Now what we need to do, we will solve this very function again. Okay, so this is our optimal quantity. We will solve this. Let me write it like this. So we have q is equal to n minus b minus t upon 2m plus a. Okay, now what we need to do, we need to find the what we call total tax revenue. Okay, what will be the total tax revenue? Let us denote, this is being given us here, so this is the total tax revenue. Let us denote our total tax revenue will be equal to the tax rate, okay, into quantity produced, profit maximizing quantity produced. Okay, so what is our t? T is as it is. What is profit maximizing output? That is this very function. So let us multiply this, n minus b minus t upon 2m plus a. Okay, so this will give us the total tax revenue. So this t is multiplied to each of these terms, so we can write it like this: n minus b t minus t into t is t square upon 2m plus a. Okay, I hope I am making myself clear. So what I mean to say that total tax revenue. Okay, total tax revenue. What is the total tax revenue? Tax rate times the output produced. Okay, so tax rate is t and output produced, that is equal to this very thing here. Okay, so this is our t. Now what we need to do, we need to find out the, that means the government wants to maximize the total tax revenue. Okay, so obviously what is maximization requires, maximization again requires, so let me write here, maximization requires to fulfill two conditions. Okay, two conditions. What are the conditions? FOC, first order condition, and second order condition. Okay, always when we have to maximize, let us say this, first we need to find the slope, and second we need to find whether after attaining the maximum the slope is negative. Okay, so this is for first order condition. To find that the slope is negative after attaining the maximum, we use second order condition as I have explained it earlier. Okay, so वो पे भी मिटाओ नहीं हो. ओके, नो प्रॉब्लम. ओके, माफ करना, गुस्से में ऐसे वैसे निकल जाता है. सो what we need to do now, let's take to get the maximum tax rate, what we need to do, we need to differentiate this tax revenue function with respect to t. That means dt upon d small t, okay, should be equal to 0. That means the derivative of the tax revenue function with respect to tax rate should be equal to 0. So let's take again the derivative. Okay, so the derivative of t is here 1, derivative of t square is 2t, implies we get, since the derivative of t is here 1, so we are left with n minus b only, minus derivative of t square is 2t. What is this 2t? Nothing, upon m plus a, simple differentiation. Okay, so since these are the constants here, we don't need to differentiate here. Actually it is like this. If you want to, if I want to make myself clear, it is like this, n minus b, we can write it like this, upon 2 m plus a t, then we have minus again 1 upon 2 m plus a t square. Okay, if we want to take derivative with respect to t, the derivative of this t will be 1, so we are left with this thing, derivative of this t square will be 2t. Okay, so we have n minus b and 2t on denominator, on a numerator, and since denominators are same, we can add up them again. Okay, so I hope I make myself clear how did I take the derivative here. So and we set it obviously equal to 0. Okay, now let's solve this very thing for a t. Okay, if we solve this for t, if we transpose this term to the RHS, it will get if I try color kaiser pattern with 0, it will become, this term into 0 will become 0. So we are left with n minus b minus 2t is equal to 0, or if I transpose this 2t, it will become positive, is equal to n minus b, which implies t is equal to n minus b upon 2. Okay, this is the optimal tax rate that will maximize the government's total tax revenue. Okay, so this was the first order condition to make it, to make sure, okay, that we are actually at the maximum. We need to check the second order condition. Second order condition simply tells us the derivative of tax revenue, second derivative of tax revenue with respect to small tax rate should be less than 0. And what is the first derivative? Sorry, first derivative was this very thing. Okay, now the second derivative will be the derivative of first derivative. Okay, so since this is first derivative, to get the second derivative we need to differentiate first derivative again. Okay, simple stuff. So what is our choice variable here? T. Okay, so t is only on this side, since no t is involved in this term, so this will become 0. So we are left with the derivative of t is here 1, so we are left with which implies d square t upon d small t square is equal to minus 2 upon 2 m plus a. Okay, which obviously is less than 0. Okay, because m and a they are both greater than 0, there is no way that this term should come out to be positive. Okay, I hope I make myself clear. So the tax rate that maximizes the government's total tax revenue is this very thing. And if I want to show it graphically, so I don't know whether I will be able to show it not. Yeah, so it will take time. Okay, let us say this is the demand function of the monopolist, this is the marginal revenue function of the monopolist. Okay, this is the marginal cost of the monopolist. Okay, marginal cost, demand, marginal revenue. Okay, now before the imposition of tax, okay, monopolist would have been selling at this price. Okay, when tax is what we call, when the per unit tax is being imposed, obviously the marginal cost will shift rightward, so this will become like this. Okay, so this is our new tax. new marginal cost. Okay, so marginal revenue is equal to marginal cost. So initially we are producing this after the excise tax rate is being uh, imposed. Again, let me write it here. Again, the monopolist will equate this marginal cost and marginal revenue. So at this point it is being equated, so he will be selling at a price p, let us say p star. Okay, and what is the difference between p and p star? So this is our n minus b, n minus b upon 2. Okay, this is the tax rate that will maximize the government's total tax revenue. I hope I make myself clear in this video, so this is not necessary to show you it here. So the question was up to this: the maximum tax rate that maximizes the total tax revenue of government is equal to n minus b upon 2. Okay, I hope I make myself clear in these videos. If you like these videos, please share with your friends. That is the only motivation for me to keep going on. Okay, this is the free stuff for you people. I don't charge any single penny for you. Okay, I just take the questions from you. So thank you.